All right, so why do we use algebra? That is a question that we always have from people in various ways. And let's be fair, that's probably a question that most of us have asked in our own life. Why do we need algebra and higher level math? We have a customer that sent us this note that said, we've been asking around to see if any adult says that they use algebra. But when they describe what they do, it is never anything like this, but things that are rare, which seem more regular arithmetic. And I think she's talking about some previous context in the email. We are literally having our kids do algebra and I think she means, are we literally having our kids do algebra to stimulate their brain so people don't say that they didn't get a good education? It's an interesting question. Why do we study algebra? There's not many of us that are sitting there popping open and solving quadratic equations, solving various types of equations in the way that we see it in the algebra book anyway. So the question is kind of a multifold question. So I want to just kind of give some kind of just big picture examples, but also some really kind of common sense examples that we do see every day. And we take it for granted that they are basic arithmetic. So first and foremost, if you go into any higher level fields, you're probably going to be using algebra, and I include things such as business, and it doesn't mean college degree. I'm constantly using algebra in a business context. And sometimes that's done for me with things like Microsoft Excel and other tools, but it's constantly out there in front of you. Your profit, cash flow kinds of things. How much do you spend to buy goods and profits? How much do you spend on goods that you're going to resell? And then is there any profit left? And that calculation is algebra. One that we find ourselves in quite often is if we order a whole bunch of material that has, the more we order, the less the shipping. That's kind of what it turns out to be, or the less the shipping per unit. But do we need thousands of these things around to sell? Probably not. So kind of where is the balancing act that we have to deal with in terms of money? And so for a lot of us, money is a great place that this type of stuff shows up. So, but let me kind of bring you down to some kind of everyday type things that we use even in our household, right? So I'm going to look at everyday algebra that we are using, and let's be frank, some of this you might not think of as algebra. But let's just go over here and take a look at it and see what it looks like. Let's say that you have a $500 for the week budgeted, or that's your spending money, carrying around money. You have already spent $200 on groceries and $120 on gas. How much is going to be left for eating out? Now that sounds like it's subtraction, right? That sounds like what I've got here is it's $500. That's how much the total I started with is equal to the 200 I spent plus the 120, and then plus whatever that is, right? What's left? Now that what's left is the x. It's the variable, right? So this is an algebraic equation that we're dealing with here. We don't always think of it that way, but when I solve this, then I just do some subtraction here. I end up with x is equal to 180. Now, and I think this is probably the example, we're using algebra for what we think is basic math, but it's not basic math. We are adding some and subtracting, but the fact that you are starting to put variables in there, like how much is left, that is where it comes to algebra. There's what we call an abstraction, because it's not just what's 5 plus 3 plus 2. All right. Now we could go backwards and maybe make this into just a general equation, but this is solving for an unknown, right? The unknown is how much money do I have left, and that is basic algebra. Another one that we would see, let's think we have a recipe. So there's just one example here. Second example would be a recipe. And what happens if you have a recipe that serves four, but you have to feed 6, right? It's a common thing, right? We recipes has this many people, we're adjusting it. Now, if you're like me, we'd probably just double it, just let's have some left over. But a lot of times, especially when you got big family gatherings and things like that, you are trying to make adjustments to recipes, or you're going the other way. You have a recipe that feeds a lot of people, you're trying to feed a few. So what happens is we have well, if it was originally built for 6, originally built before, but now we need 6, we need bigger. So there's a 6/4 ratio, which is equal to 1.5 if I do the math there. So if it called for 2 cups of flour, says 2 cups of flour, now I have to say there's going to be 1.5 that amount, right? Because this was the 2 cups was for serving 4, but now I am serving 6. So I have to multiply this by 1.5, and that's going to give me, I now need 3 cups of flour. And of course I can do this with all of the other foods that I'm using for the recipe. But this first one here is solving for an unknown. If you can read that writing. And the other here is a proportion. You've set up a proportion. And I definitely spelled that one wrong. But if I write it ugly enough, you can't tell the difference. Well, maybe that's right. So we have set up a proportion here to solve this problem. So again, these are 2 very kind of common things that we see. What's another one we see that we do this one? We don't do this one quite as often as we used to because we got things like GPS and Google Maps and things like that. But common sense, we would probably still do this, and we probably do this in our head. It's the distance equals rate times time. We're on a trip. If there is a trip for 180 miles, I got to go 180 miles, and I'm going to say, well, I need to get there in 3 hours. All right, so how fast do I have to be traveling? Now that's a little unpractical. We'd actually probably solve this the other way. So I did this one backwards because you probably just aren't going to be able to pick the road you go the speed you want to, but you get the idea. So this is a miles per hour equation. And so it's the rate, it's equal to 100 miles over 3 hours. And so I'm going to be traveling over at 60 miles per hour. Now this is a rate versus time problem that you see a lot of, especially in word problems in algebra. And we do this. We just don't usually do it like what I'm doing right here. We don't usually write these things down. Sometimes we solve them in our head. But the fact that we can solve them in our head means that there's some algebra there, whether we got it through an algebra class or whether God just gave it to us. I don't know where you got it, but you are doing algebra. So there is a couple of examples here. And so as we look at those examples of basic algebra in the home, now what about in the professions? Now I'm going to stay away from the things like engineering and actuarial sciences and the things that are really intense mathematics and is kind of built into the DNA of everything you do. But let's just kind of talk about some more common things that we see out there that we'll call them the trades, okay, with people that are in some of the trade areas. For instance, electricians. One of the main things of electricians or electrical engineers is there's what's called Ohm's law. It's one of the fundamental laws of basic electricity. And it says volts is equal to IR, and for some reason I stands for current, but don't worry about that. So it's amps. So you've seen when you look at a refrigerator or something, it runs on 120 volts. It pulls so many amps, or uses so much power. And there's some other equations here that related to that. But generally the volts is equal to 120 volts in the United States, and generally our circuits, like your circuit breaker, your fuse, whatever you have, for most of the things that go to the outlets around your home are rated at 15 amps, just the kind of general where you plug lamps and things in. Sometimes refrigerators, microwaves, kitchens may be higher, but this is just the ones you're going to have around your den in the bedroom. So the equation here is what's the resistance you can put on that. And so now we as individuals probably aren't doing this very often, but we would be looking at the resistance is 120 volts divided by a 15 amp circuit, and there could be as much as 8 ohms there. That's supposed to be 8 with a little ohm symbol. Now we do see doing the equations like this when we're doing power in our house, because if we look at the power usage in our house, this is not perfect, but this is the general rough idea. It's the power is the volts, which for most of our homes in the United States is using 240 volts, and it's volts times amps. So I'm gonna just say volts times amps. And that's how much power we use. Now that we care a whole lot about, because that is how much we pay. We're billed by power usage, watts, kilowatts. So we care a lot about that one. So if you are turning on air conditioners and things like that, the voltage stays the same, right? That's provided. But if you're turning on air conditioners and things like this, and big appliances, they use a lot of power. So if you go out to your circuit breaker, they'll have like 15 and 20, and then you'll see some that say 30 that may be running your stove for your kitchen. That's 30 amps. When you turn your stove, you're pulling up to 30 amps. You may see a 30 or 40 or 50 for AC type stuff. So when you're running your air conditioner and heaters and all, they may run up more. That's why they are charging more, because we see the amount of volts that we use times the current. And I'm going to just write this as current. And this is the thing that goes up. That's the variable, depending on what appliances you turn on. So you may be saying to yourself, well, I don't really do that. But sometimes when you're in a situation where you're like, what's consuming so much power in my house? We might do that, or some electrician or somebody might do that for you. And so these are both algebraic equations that we would see that are just basically what we would call, for the most part, a simple linear equation. But then when we look at construction, and a common thing with construction, this is electrician, this is construction, is roof rise. There's other things too, but your roof might have it may have a 6-foot run over it may have a 6-foot rise. I'm sorry, it goes up every 6 foot for every 12-foot run. So we would call that a 612 roof. The pitch of the roof, if you talk to a roofer, would be 612. Well, that slope is rise over run. So that's 6 over 12. That means it's a 0.5 slope. So that is a slope equation. So that gets into your linear equation. We are calculating slopes. This is being used. Now, if you've ever built anything, and it doesn't have to be a roof, but if you've built anything using materials with wood, you might find yourself calculating how much wood do I need to do these various things, and you probably are doing algebra. Again, whether you think about it or not, you're doing algebra. So let's look at another one. The miles per gallon, mechanics using miles per gallon. I'm not going to write that one down, but if you are running 360 miles It's 12 gallons. You can know now your car is using 30 miles per gallon. You're just doing some math, and it seems like, well, this is just a vision. It's not. We're again solving for unknowns, solving for equations with unknowns. All right, so those are a couple of examples that some of them you are using every day, but some of them we're using it in the trades. And these aren't, when I'm picking on these trades, I'm not suggesting these are college degree type of things. These are people that are just out there, they're doing work. They may be trained in it. They may be trained how to use these equations in this math, but that's the math they're using. It's algebra, right? So if you go into a trade such as electrician, such as construction, such as, well, anything that you've got materials. We bought some flooring for a house not long ago, and they were doing algebra. They didn't know they were doing algebra. They were calculating square foot, materials, price per foot, and all this kind of stuff. They were doing algebra. So if you know algebra and it's kind of ingrained to what you do, and it ingrains really quickly as you see you are doing it, and you may not think about it, is you're ready. If you don't have that as a basis, well, you're handicapped and you're kind of coming up. And a lot of people, I know friends of mine who train people for the trades. He trains people to use tape measures and things like this to do plumbing, to do electrical, to do building, whatever. And he has his different paths that he takes people on. It's not a school. I forget how I think he gets paid by the employers. And he says a lot of people he said the very, very basic things they can't do, and it's because they don't really have this understanding. Algebra is about relationships between things. There's relationships between rises and runs. There's a relationship between cups, and ounces. There's all these relationships, and they're numerical relationships, and we solve them through basic algebra. So knowing this stuff, super, super important. And again, to not be handicapped. Let's look at another one that maybe drive close to the heart to some people. Your cell phone plan. So a lot of cell phone plans, they might say something like it's going to be $30 a month plus. I'm just guessing $10 per gigabyte or something. I don't know. So in other words, this is a plan. We charge you a certain amount, and then we charge you for usage. Or you could plan. This is plan A, or plan B. They might have is $50 per month. Okay, so are you going to pay $50 a month or $30 and hope you don't end up at $60 or $70? So, and the question we oftentimes ask in these things, and me and you do the same thing. At what point are they equal? Like you're looking at, hey, here's how much gigabytes I use typically. At what point are these things equal? So what we have is this really turns out to be 30 plus 10x equal 50. Now you might be saying, what in the world? How did you come to that? Well, if there's a plan that's 50 and this other plan, at what point are they equal? It's when the 30th plan plus X units, there's your variable, so many units of 10 gigabytes will equal 50. That's what I want to know, is how many gigabytes do I use? Now, if I solve this without boring you too much, in case we're not past that point already, we are going to get, there's 2 gigabytes. Okay, so if you use more than 2 gigabytes, plan B, paying $50 a month, is cheaper. Now that's algebra in action. And you probably do that. You probably wouldn't do what I just did in the way I did it and write it out, but I'm writing out the algebra for you, and you are probably either doing it on the back of a napkin, kind of thinking through this. You might write a table. You might say, well, if it's 1, if it's, if you won't call it X, but if there's 10, well, that's going to be, well, okay, that's if it's 1 gigabyte, well, that's going to be $40. Well, that's less. That's a good deal. If it's 2 gigabytes, well, it's going to be 50. Okay, so that's break even. Okay, if it's 3 gigabytes I'm using, and you might kind of do it by just putting in numbers for the X here that I have. You're not calling it X. I appreciate that. You're not calling it a variable, but it is. That's what you're doing. Algebra is taking the kind of things we think through as a person, right? We all do it. It doesn't matter whether you are trained in algebra or not. You know math, and you are doing this stuff in your head. What algebra tries to do is teach you a systematic way of looking at this. And when you understand a systematic way and you're not just, it's all not cluttered up in your head, you can do more with it. It becomes more powerful. You become more trusting of your answers, and you become more valuable in the workplace. So everyday life, we see these things. Now I'm gonna just throw a couple of little things out at you that we do see in everyday life. We see it show up in movies a lot of times, like what was somebody saying, the movie with the boy genius, whatever. I forget the name of it, but let's see if I can find it. He, kind of a pop culture thing. In the movie Mean Girls, for instance, there's an algebra. They have a mathlete championship, and it's algebra question. It shows up in culture. On the NASA movie, The Hidden Figures, you see that algebra was made to make the rocket go. Most of us aren't going to be rocket scientists there. We see The Big Bang Theory. That's the one I was thinking of. Oftentimes, algebra is the punchline. Now, so this is like, I need to understand enough algebra to understand comedy. Kind of. A lot of comedy is based upon some fairly intellectual things, if you will. So we'll see this. We'll see this all come up all the time. Let me get. I've got too many screens up here. All right. So one of the other things that we see is splitting your costs with friends. You go to a restaurant, or you're renting an Uber and it's $45. There are three of us. You're doing okay. Well, that's 45 divided by 3, and let's do the math. You're doing this. You're just solving for an unknown. Netflix, you're comparing. There's a $15 fee versus Hulu for $8 and a $2 add-ons. You have all these subscriptions out there. There's a million opportunities for people to take your money. For you to get goods and services out there. But when you start comparing plans like that, you're looking at linear equations, kind of like what we were just looking at. Sports stats. If you're into baseball, for instance, a pitcher throws strikes 70% of the time. How many strikes in 20 pitches? And these guys if you watch baseball, that's all they talk about, stats. And it's getting to be the case with football and everything else. Stats has become a big issue in all kinds of sports. Home improvement, we see this so many times. I got so many square feet. Their tiles are this big. How many tiles do I need before I go to the store and buy a tile? We're doing that. That's algebra. Maybe that's even a little bit of geometry, but mostly algebra there. Gas mileage, as we've already said that. So look, we are using this stuff all the time, and I could give you some more complicated things that we are seeing maybe in some of the trades. We see algebraic thinking come up in music, even geometric thinking coming up in music. As a matter of fact, there's a very strong tie between music and mathematics. In so many sports and physics and mathematics. But anyway, algebra just shows up all the time. It shows up in your budget, your recipes, and in your roof. Your cell phone plan, your gas mileage, gas tank. You are probably using it. You may be the person saying, I will never use algebra in my life. I threw out that book after I got through the class, and I'll never see it again. But you were seeing it before you got into algebra, and you were seeing it after you got into algebra, right? How many of us could speak English, or whatever your language, but let's just assume English. How many of us could speak English before we took an English class, right? What did the English class teach us? It taught us the structure, the syntax, and how you think about things. It probably made us better at speaking. So because it creates a framework for the language, and we were using it already. You were using math, you were using algebra already. This is giving you the framework. So, all right. If your students are working through algebra, and especially if they're asking these kind of things, we love to hear these kind of questions. Shoot us an email. Tell us where you are. Tell us what your hobbies are. Tell us what you enjoy doing. We'll show you how this shows up in your life. But if you're working through algebra, we have a Jacob's Algebra series using the Jacob's textbook, and we have a video series that goes with that walks you through the course and the material. Jacob's Algebra as a textbook, and especially Jacob's Geometry, when you get into that, show you a lot of real life activity. But there's still a lot of just kind of basic math stuff, so people are still asking, right? So if you want any of that, if you're looking for that, there'll be links down below, and we are open to any questions that you have, any way we can help you get through the struggles of math in high school years. You just let us know. And we will be back here with you next week.